Hi, this video is going to talk to you about the linear search algorithm. I'm going to talk you through how it works and the stages involved with a worked example. But before we go into that, I'm just going to do a bit of a summary of what linear search is. It's basically looking for a piece of data. Unfortunately, lots of people get confused under pressure between a search and a sort. A sort is putting in order, a search is looking for something. Now, what we're looking for, it doesn't really matter. It can be an integer, it could be a decimal, real number, it could be a piece of string. But what we do need is a list. That array or list, I'm going to use the word list throughout this video, holds those pieces of data that we want to interrogate. We also need something to look for. We call that the target data. And if that target data is not there, that's okay. It just, we need to know that that's not there. And then whatever we need that check for, then, the code can continue. So the two outcomes are, the data is in the list, the data is not in the list, and that's okay. We're going to use a function to do that. I think is the best proof. But also you need to be able to be confident in writing iteration, for loops, and selection. Now, the linear search is often used for small lists, small arrays, not many pieces of data to interrogate, because a linear search will look at each item in order, one by one. Saying that, the data being stored in that list doesn't have to be in any particular order. It makes no difference to the efficiency of the algorithm itself. It's great in terms of memory usage, doesn't take up a lot of space at all. Unlike other divide and conquer algorithms, like the binary search, which creates sublists, and that can be more demanding on the system. Finally, there is a situation where the linear search rules and becomes number one, is when you're searching for an item and it's that very first item in that list. That scenario, the linear search would be more efficient than a binary search, and we'll demonstrate that later on in another video, but not for today. But anyhow, I'm now going to talk through how to set up and understand the binary list. We're now going to work through the linear search. So the linear search is a fantastic searching algorithm, a slow one, but still a fantastic one, and a relatively easy one to understand and work out. First of all, in order to get a searching algorithm up, we need to have a list or an array that we're going to go through to see if the item we want is in that list. Now, the list itself can be of any data type. It can be an integer, it can be a decimal number, or it could be string. And it doesn't even matter if it's not in order. In fact, it makes no difference if it's in order or muddled up. It really makes no difference at all. You also need some target data or a piece of data that you're looking for. And what we're going to do is we're going to compare that target data against each element in that list until we found what we're looking for. Now, if it's not there at the end, well, we need to stop. We need to stop once we've checked the final item and the item's not there. So there are two outcomes. We stop at one point because we found the item, or we stop because we've checked all the items and the data is not there. So we need to compare the target value with each element in the array or the list. If it's found, we stop. If it's not, we move on to the next item and we repeat that comparison. So let's have a look at this list we have here. And here we've got 8 values, 15, 12, 8, 1, 11, 6, 9, and 2. They're all integers, okay, whole numbers. And what we're going to be looking for next is the number 1. So this is our target value, our target data. And what we're going to do is just basically write it in a way that maybe is, you might know as sort of pseudocode in between programming and actual code. So we use double equals here. So 15 equals 1. No, it doesn't. So what we then need to do is say, okay, we've done 15. We need to move on to the next item. We look at 12. We compare 12 to 1. Again, it does not match. So 12 is out. And we repeat this process over and over again. And as you can see, it's a quite long process comparing each item against the target data. But we're going to carry on anyway. Is 8 equal to 1? The answer is obviously no. And we keep moving. The next item is 1. 1 is equal to 1. We find it and we stop. And we return a value that tells the algorithm that we've found that data. Some important things to know about the linear search algorithm. It's not very efficient with big lists or big arrays. It takes a very long time. It doesn't have to be sorted, and I think that's a positive thing. That's a benefit. It doesn't have to be in any particular order. Also, it actually doesn't take up a lot of memory. Unlike other algorithms that you can use for searching, like binary, there's no need to produce what we call sublists. Every time you make a sublist, you need extra segments of memory, sectors of memory, to store those sublists in. So we're doing a very simple comparison where we don't need to use excessive amount of memory. There is one situation where the linear search is the most optimal, and I think you can guess it. It is when the item you're looking for is in the very first position. If that's the case, if you use a binary search, it would take you longer to find that data than a linear search, but only if the value you're looking for is the very first item in that list or that array. That's the only time. So just to recap, you will need to have a list, target data, whether it's fixed or you allow the user to type the number in or the letter in or the word in, and you need to repeat, so you'll need to use iteration to go through each item in that list. You use selection to compare the two pieces of data, the target data against the element or item in that list or array. Remember, selection is the use of if. Finally, if it's in that list, we return a value. If not, we return a different value. Now you might be thinking to yourself, returning a value, now that sounds familiar. That's because we'll be using a function to do that for us. And in a separate video, I've shown how we can achieve that.